Hello everyone and welcome back to my channel. In this lecture, I am going to explore a very important and fundamental concept of calculus, that is limit of a function. I will try to explain it with some real life examples. So why do we need limits? To make it simple, let's begin with some real life examples. First example is pizza size problem. Suppose you have one pizza. First you eat half, okay? Then half of the remaining, then again half of that, and so on. After one bite, suppose half remains. After the next, a quarter, that is 1 by 2 raised to the power 2. After that, 1 by 2 raised to the power 3 means 1/8, and so on. So pizza size after n bytes, that we denote by P of n. We can write 1 by 2 raised to the power n. So question is, what happens as the number of bytes keeps increasing without end? So does the pizza ever completely disappear? Means pizza size becomes 0? So answer is not really. As the number of bytes increases, pizza size Pn gets smaller and smaller, means approaching 0. Okay, but never becomes exactly 0. Mathematically, as n tending to infinity means number of bytes increases without end, then size that we are denoting by Pn tending to 0. So in terms of limits, we can write limit n tending to infinity Pn, which is limit n tends to infinity 1 by 2 raised to the power n, it will be 0. So in this example, even pizza size never becomes 0, but it gets closer and closer to 0, and limit describes this behavior precisely. Second example is bridge with a gap. Now think of a bridge with a small gap or hole at some point x naught. If hx denotes the height of the bridge above the river, clearly height of the bridge at this point at gap is not defined here. Now question is, what is the intended height of the bridge at x naught? Intended height means approximate desired height that we can achieve. So at x naught, height does not exist. You can see in the figure, but we can try to have some intended height, means approximate height. So what we do, we approach the gap from both sides. Okay, means x goes closer and closer to x naught from both sides. Then hx values also approach to the height. Okay, and in terms of limit, we can write limit x tending to x naught h, and this value will be the height at x naught. Okay, so in this example, even height at x naught, that is h of x naught, does not exist, but the limit gives the intended height of the bridge at x naught. Here is another mathematical example, that is hole in the graph problem. So here function is defined as f of x equal to x square minus 1 divided by x minus 1. This function is undefined at x equal to 1 because denominator, which is x minus 1, it becomes 0 at x equal to 1. See the graph of this function. Clearly at 1 function is undefined. Okay. Now question is, what value does the function approach as x gets closer to 1? See, if we simplify the function as x square minus 1, we can write x plus 1 into x minus 1. Okay. And cancelling the common factor here. So what we will get? X plus 1. Okay. So in terms of limit, mathematically we can write limit x tending to 1 function f of x. So function f of x is x plus 1 after simplification. So limit x tending to 1, x plus 1, it will be 2. Okay. So in this example also function is undefined at x equal to 1, but the function value we are getting, that is 2. Means as x approaches to 1 from both sides, the function gets closer and closer to 2. So we can say 2 is the limit of this function. Let's discuss two special cases. Case 1, function defined but limit still matters. Okay. So function is x square for x not equal to 2, and at x equal to 2 function value is 5. This is the graph of this function. You can see at 2 function is undefined here, but the value of function is 5 at 2. See, okay. So function value at 2, it is 5, and if we think about the limit, then as x gets closer and closer to 2 from both sides, function gets closer and closer to value 4. Means function approaches to 4. So limit is 4. So in this case, we see function value and limit value both are different. In this case, function is undefined but limit exists. So function is sin x by x. This function is undefined at x equal to 0, because if we put x equal to 0 here, so you see sine 0 by 0 means 0 by 0, 0 by 0 form we are getting, which is meaningless form mathematically. So now question is, what is the limit value of this function at x equal to 0? So see, this is the graph of this function sin x by x. So clearly function is undefined at x equal to 0, but if we talk about the limit of this function as x approaches 0, it is 1. Graphically you can see as x approaches 0 from both sides, okay, from left, from right, what is the behavior of function? Function also approaches to 1. As x approaches to 0 from left, function approaches to 1. x approaches from right, function approaches to value 1. So limit of this function as x tends to 0, it is 1. So in this case, we see that function is undefined but limit exists. Let's summarize the key points about limits. Limit of a function at a point tells us what value function is approaching. Okay. Limit works even function is undefined or defined at that point. Means limit does not depend on the function. Function is defined or not defined, we can find out the limit. Okay, limit may exist. Limits help us to capture the approximate behavior near the point. Okay, which is very essential to understand the continuity and derivative concepts. Okay, that's all for this lecture. If you found this helpful, please like, share, and comment to my videos. You can subscribe to my channel for more videos. Thank you.